Hi everyone, welcome to Chapter 7. This one is on hypothesis testing. Let me start off by just reminding you where we left off with Chapter 6. At the end of Chapter 6, we learned about confidence intervals. And we learned that we can compare the confidence intervals for two or more means and apply a, somewhat oversimplified rule, but I will talk about that more later. But we learned a fairly simplistic rule to try and figure out why two sample means are different from each other. And we learned that if the confidence intervals for those two means overlap, which means they share values in common, then we are going to conclude that the most likely reason why the two means are different from each other is because of sampling error. However, if the two confidence intervals, because we always compare means 2 by 2, so if the confidence intervals for two means do not overlap, then the most likely reason why the two sample means are different is because of sampling error plus something else, right? Maybe some sort of treatment effect. But there's, it's unlikely that the two sample means are different just because of chance or sampling error alone. Something else is going on. And remember, that happens when there are two confidence intervals, when those intervals do not overlap. But we have actually, some would argue, more sophisticated ways of determining whether or not means are different because of sampling error or a treatment effect. And those ways are by using inferential or statistical tests. So we have a whole bunch of tests, like a whole bunch of different power tools at our disposal to try and figure out why we are getting the results we're getting in an experiment or study. Because remember that when we do research, very, very rarely do we have access to the whole population. We study samples, right? And we do our experiment or study on those samples, and then we find something. Well, we've got to have a way of figuring out whether or not what we found is just a result of sampling error, which, remember, we're bound to have. It's not a question of if, it's a question of how much. So when we do our study, we expect to see some sort of findings. But again, is what we found likely because of sampling error alone, or is there something on top of that, some sort of treatment effect? So I like this analogy here for hypothesis testing because what you're going to learn is that when we do run inferential statistics, these tests that are going to tell us whether what we have is sampling error or sampling error plus something else, what these tests have in common is that they're always pitting two competing hypotheses against each other. So one hypothesis is going to say that all you have is sampling error, there's nothing else going on. And the other hypothesis is going to say, no, that's wrong. There is sampling error, but there's something on top of that. So again, hypothesis testing, or these inferential statistics that we're going to learn about, are always testing these two hypotheses, sampling error alone versus sampling error plus something else. But for you to really understand the results of inferential statistics, these statistical tests or power tools that we're going to be using, you have to understand how they work and what their limitations are. Otherwise, it's like putting a power tool in the hands of a 5-year-old and saying, you go get them, slugger. All right, we need to make sure that we understand exactly what these statistical tests, these inferential tests, are doing. Okay, so before we start with hypothesis testing and all the ins and outs, hold on, my computer seems to have frozen here. Well, this is interesting. Oh, here we go. Okay, we need to talk a little bit about politics in academia. Now, you might think, wait a second, universities, colleges, there are politics here? Absolutely. There are just as many politics, if not more so, in academia, I think, than there are in, the public sector. Now, one of the politics in academia has to do with this publish or perish saying. If you speak to any faculty member and you ask them, what is this publish or perish? What does that mean exactly? Well, you better sit down because you're going to hear an earful. Okay, so I will not go into too much of an explanation, but I do need to explain it to you a little bit because this will help you to understand the necessity for having these hypothesis tests, these inferential statistical tests. Okay, so what does publish or perish mean? Well, it means that when you first get hired by a university, typically this applies more so to universities than to colleges, there is an expectation that you are going to work towards tenure and rank advancement. Now, I think a lot of you know what tenure means. So essentially what you're doing is you're working as, you start off as an assistant professor when you first go into a faculty role. In most cases, you start off, again, as an assistant. And ultimately, what you're trying to do is you're trying to advance through the ranks. And after a period of time, it depends on the university, it could be 6 or 7 years, you apply for tenure status. Now, what that means is once you have tenure status, generally people what they think it means is we can never fire you, and that's not the case. But it's supposed to mean that you have proven yourself, and now for us to fire somebody with tenure, we have to show that you are no longer doing your job. Whereas when you were working towards tenure, the onus of responsibility was on you. You had to prove to us that you're worthy. You had to prove to us that you're doing your job. So after tenure, that switches around, and now an administration would have to prove that you're not doing your job. Anyways, there's some job security that comes with tenure. Not much, but a little bit. Okay, now the other thing I mentioned is when you start at university, you work your way up through the ranks. So that means you start as an assistant, and then you go to associate, and then you go to full. And there are some people who never make full. Okay, what is required in most places for you to advance from assistant, associate to full, and for you to get tenure is you have to publish. And not just publish anywhere, but you have to publish, among other places, these peer-reviewed or scholarly journals that you learned about at the beginning of the semester. Now, that seems like, okay, well, I don't think that's too hard, right? You do an experiment, you do a study, you submit it, and you get accepted. Except it's not that easy. Right, so I got this kind of little cartoon here. I think a lot of faculty would prefer this method of getting published. Just make it through the line of torturers, and if you succeed, yay, your paper is accepted and it's published. Okay, so it is not that easy. What we have to do is we have to find significant results. Now, this applies to the behavioral sciences. I'm not saying that the same criteria is going to be applicable. Let's say if you're a historian and you're publishing in some journal related to the field of history or English, etc. But in the STEM sciences, that's science, technology, engineering, and math, in STEM, we need to show that we have significant results. So what does that mean? It means that whatever we found through our research, and again, we're using samples, we have concluded that the results are probably not due to sampling error alone. That is, we have found something in addition to sampling error. And when that happens, we say the results are significant. So the reverse, if we only found sampling error, then we would say the results are not significant. Okay, so make sure you write this down because this is hugely important. If the results are thought to be the result of sampling error alone, we would say that the results are not significant. On the other hand, if we conclude that the results are likely due to sampling error plus something else, some sort of treatment effect, then that would mean that the results are significant. Okay, so we have to find these significant results in order to get our papers accepted. And the more papers we get accepted, the more likely we are going to advance from assistant to associate to full, and the more likely we are to get tenure. And this creates a little bit of a problem here because journals, again, in order to get your paper accepted, you have to show significant results. Well, that puts a lot of pressure on faculty, right? They need to get those significant results if they're going to advance through the ranks. They need to get those significant results in order to get tenure. So if there were absolutely no rules, none whatsoever, any researcher could look at their data and say, oh yeah, that's more than sampling error. My results are significant. Publish me, please. You see how this would create a fiasco, a mess? If it was up to every single researcher just to decide him or herself whether the results of their study was significant or not, everybody would be claiming that their results are significant. So even if, let's say you have mean 1 is, 10.2, and mean 2 is equal to 10.3, well, that may be a very, very small difference. But again, if there's no rules, the researcher is going to say, yeah, so what? It's still significant. And so what we recognized is that there's got to be a common set of rules that everybody has to follow. And the rules have to be such that we're going to let the data decide if the results are significant or not. The decision needs to be very objective. We cannot leave it up to the subjective whims of the researchers. So hypothesis testing was created so that everybody would have to use the same set of procedures. Everybody's data would have to meet certain criteria. And if they met that criteria, then you could say my results are significant. And if they didn't meet the criteria, then you'd have to say my results are not significant. All right. So again, that's what hypothesis testing was created for, is to provide us with those set of rules. And through hypothesis testing, we come up with or have developed a number, and by a number, I mean dozens, of different statistical tests that we can use to try and figure out whether your results are significant or not. In Chapter 8, we're going to start learning about those different tests and when to use each test. Now, you can breathe a sigh of relief. You're not going to learn about dozens of these. There will be, I think, 11 maybe, but they all are similar. There's only like 1 or 2 differences between them. So once you memorize one, memorizing the other variations becomes easier. So don't worry too much about that.